Number 2. Oh, let's see what's next. Let's see if I can put my hands on it. Let's do y is equal to f of x is equal to 1/3 x minus 4 quantity squared. Okay, let's do this one a little bit different. Let's do the vertex first. We did go back and fill everything in, didn't we? Yeah. Axis symmetry, yes. So what's the vertex going to be?
4, 0.
Positive 4, and then there's nothing added out here, 0. What's the axis of symmetry? X equals, no, x equals 4. It's going to go through the x of the vertex. It's going to be the vertical line that goes right through that vertex. And then your zeros, or your points, there's your symmetry to the left and right of that vertex. All those points are going to be symmetrical. And we don't know the y-intercept yet. And I'll go ahead and just put 0 blank. And we don't know x-intercepts, if there are any or whatever. So we'll just put x-intercept, domain, all reals, range. Okay, if it opens up, because it's positive, the range is going to be greater than or equal to some number. Well, we actually should already know. It's going to be, if your vertex is at positive 4, 0, it's going to be y is greater than or equal to 0. So see, most of this you can do without the calculator. And the more you can do without it, the better you are on the ACT time-wise. It's just time-consuming. That's the reason I only gave you 6 of these, because they can get very messy. Let's go ahead and graph it, and then we'll use the calculator. Now, I'm not going to connect them. Oh, now my vertex is at 4, 0, so I'm going to move that y-axis a little bit more to the left, because I need 4 and then a little bit to the right of it, you know, to be able to do the points. I don't know why I made it so huge. Okay, the vertex is over here. And the stretch is 1/3. Now remember, you go up 1/3, it's a little bit less than half, and go over 1, over 1. But I'm not going to connect them, because I'm going to show you something your calculator will help you make it a little more. I mean, it's close enough, but I think you see that your y-intercept is going to be visible. And so I'm going to, if it's easy, I'm going to plot it, and that'll just make it easier to draw my graph. Is it required? No, but it just makes it more accurate. So I say graph the y-intercept if you can. If it's, you know, if it's 70, I'm not counting up to 70. We're ready to graph it. I prefer, now I don't know why I hit that. Let's see, let me get out of that. Y equals, okay, clear. I prefer, you know me, I like the fraction. I like 1/3 as opposed to 1/3, 1 divided by 3. And I think it'll stay in fractions if you type fractions. Remember how I get a fraction?
Second and then the x.
No, not second. It's alpha and then your x key. Or if your calculator's not updated, or if it's an older version, it's alpha y equals. Okay. If you want to write that down, I'm not writing it down. It's back in our notes somewhere. And I'm going to put the 1/3, open parentheses. Why are y'all not typing? You need to be typing. X minus 4. I'm not your entertainment today, just watching me do it. Squared. That's it. Okay. Now, we haven't changed the window, so we don't have to check window. We can just go ahead and graph it. It's a little slow.
Yeah.
And a lot of times it graphs that stuff off screen, and so it's just coming down. Just if it has got a little more work to it, I guess. Okay, you feel comfortable with it? Okay, what do we not have? We don't have the y-intercept. How can I find that? Just hit what? Trace. Now, if for some reason you forgot to look at it when it came up, you could type 0. You can just, when you're in the screen, you can type any number you want to. So 0 gives me 16/3, which is pretty good, but if I'm going to graph it on my picture, 16/3 is 5 1/3. You know, hopefully you should know that one. So 1, 2, 3, 4, 5 1/3. That's not required, but it sure makes, and I don't think I have enough room to draw it over here, but it sure makes it look more like the exact parabola. And I just kind of got it, mine just ran off the page, but there is symmetry around it on that one. Okay, what about x-intercept? Does it sit or cross? We've always called them crossing, let's see, what do we usually call them? Crossing zeros, x-intercepts, or touching. That's what I call them, touching zeros, x-intercepts, or crossing ones. So this one actually has a touching one. What is it? Where does your graph touch the x-axis? At 4, 0, at the vertex. If you only have 1, 0, it's always going to be the vertex. Because if a graph goes through the x-axis, if a graph comes down through the x-axis, it has got to come back up. If there's one crossing, there's got to be another crossing. It cannot touch without, if it's just touching, it's got to be the vertex, always. What do we not have? That's it. Number 3. F of x is equal to negative 1/4 x minus 2 quantity squared minus 1. Vertex? Elijah, what's the axis of symmetry going to be? You get caught up with me?
Okay, so it's -2.
Okay, that's a number. I need a vertical line. So it has to be, vertical lines are always x equals, and then you said -2. It's going to go through my vertex. Okay?
I thought it would be +2.
Oh, I'm sorry. Did you say 2? You said 2.
I said +2.
You said +2, and I wrote -2. I did hear you say it. Okay, thank you. You did say it right, Elijah. Okay, x equals +2. I think we got it right. Sorry. Yes, I heard you say it. I don't know why I wrote that. Thank you. And then the y-intercept will be visible when we get it graphed. So I'm going to use it. And then the x-intercepts we'll talk about. Domain is all reals. And the range. Okay, now how's this one going to open?
It's gonna open down.
It opens down, and if the vertex right here is 2, -1, then notice that all your graph is below or equal to -1. Your y's are. So it'll be y is less than or equal to -1. Now, you don't have to do it without the picture, but those are the kind of things that 60 minutes, 60 problems on the ACT that you can knock out.
How do you get the range?
Okay, you're going to have to look at you may want to go back and watch the video because we talked about it T-table wise, or you can go back and look at where did we do a lot of domain and range? Lesson 3, lesson 2 and 3, or you can come see me, but I'll probably refer you back to some of that. Okay, quick graph. I did something with my ruler. I'll just use this protractor. Okay, 2, 1, that's not bad, so just a regular X and Y axis will work. Okay, 2, -1. Okay, opens down. We're going to go down 1/4, just a little bit. It's actually halfway to half. And over 1 over 1. Oh, anybody graphed it yet? If you do, you already know your y-intercept, and you can include that in your graph. When you type that -1/4, you can either put the negative in front of the fraction, or you can put it with the top or the bottom. I usually put my negative, and then I put my fraction. And then x minus 2 squared minus 1. Okay, what's the y-intercept? -2. Now that's an awesome one because look, you can do this. It's 2 to the left of that axis of symmetry. You can even use the symmetry here. That's what my regular algebra student didn't like yesterday. I don't like those extra points. I said, but it just,
How do you -2?
you got hit trace.
I got -3.
Hit trace.
Yeah.
Now, does it say 0? Mine says 2. Did you copy it down right? Go back to y equals. Make sure.
-1/2.
-1/4. That's it. Yours is probably a little wider than ours, or skinnier. I'm trying to think which way it would go. Yeah. So what you have was right. You just didn't have the right problem. So connect them. And there's our graph. And we're ready to clean. So we're good. Let me get that.
Where do we glue this?
You can glue it anywhere you want to.
What were the y-intercepts?
The y-intercept. Oh,
Let
we
me
can talk about
ask.
x-intercept.
X-intercept.
What are the x-intercepts?
Uh,
Where does it cross the x-axis?
Oh, it doesn't.
It doesn't. Now, technically, it's none. Now, the math teacher in me goes, they're actually imaginary. But you see, you can't graph imaginary numbers on the x and y axis. And so I'm just going to say no reals. Now, if you say none, I'm fine with that because there are none that would be on this graph. But that's where that quadratic formula kind of helps you a little bit. But it all goes back to the factoring concept and all that kind of stuff. And they're actually two imaginary. You can actually say it that way. Okay, girls, if you've got a pencil to write this down, or if you want to take a screenshot, let me show you the webinar. Let me see if you can see it. Oh, it's glaring. Is it on there? Can you see it? Sarah, you see it? I'm wiggling the... And you just have to go to that site. I think if you just went to edu and said ACT something, it probably would come up. But that's it right there. Okay, did y'all get it? Okay. Sarah got it? Okay. Okay, whatever you need from me, just holler at me. Emily, you coming back, girl? Yay! Barring no disasters. I got my first shot Wednesday, so I'm doing good. Okay, I will see y'all. Email me if you need me. Okay, I don't know what we're doing in Cornerstone, so let me take this. Clean, clean, clean. Let me shut that off. What's Todd Hooper doing? He's probably needing somebody to cover his class.